So this is a question, okay? We need to basically design an EER, extended ER diagram schema for a bank database. Now here we have each bank can have multiple branches. So see, we'll have a bank entity, multiple branches, no? So we'll have a branch entity, okay? Now each branch can have multiple accounts and loans. See, we got two more entities, accounts, loans. Now the bank keeps track of different types of accounts. Now in accounts also we have subtypes, okay? We have savings, then checking account, and then we have our loans. And loans ka subtypes are car loans and home loans, okay? And now each accounts will have their own transactions. So for transactions we'll need a separate table. Yeah, so its own table. Then we have each loan's payments, no? So we'll have another table for payments. So at the very least, we'll have 1, 2, 3, 4, 5, 6, 6 entities. And then we'll have, what do you say, for accounts, we'll have two subclasses, that is savings account and checking account. And for loans, we'll have car loans and home loans, okay? And even in transaction, we can have either a deposit, a withdrawal, or a check. वैसे now let's start, okay? Firstly we'll have our bank over here, bank entity. This is obviously a strong entity, so it will have its own ID, okay? So let's say bank ID, and we'll underline it since that's the primary key, okay? Then we have a branch. So each bank will have its branch, multiple branches it can have. So a bank has branch, and one bank will have n branches, okay? And what do you say, if a bank exists, then it may or may not have a branch, but if a branch exists, then it must belong to a bank, no? So from branch ka side there is total participation, however from bank ka side there is only a partial participation, वैसे, because branch is more dependent on bank. Now each branch also will have its own branch ID. So let's just call that branch ID. Okay, BID. Or we'll just call it branch ID. Wait, branch ID. Okay. Then what else do we have? Each branch can have multiple accounts and loans. Okay. So now we need one accounts ka entity, accounts, and it can have multiple loans also, no? So we'll have one loans here. Okay, so each branch has multiple accounts. So one branch can have n number of accounts, no? And a branch can exist with or without accounts. So it's a total participation on the accounts ka side and a partial participation on the branch ka side. Because without a branch, an account cannot exist. Okay. And for the loans ka side also, the branch provides loans, no? So we'll use the word provides. I written the diamond in a slant way, but it should be a proper diamond, okay? Like this, like a proper diamond. Either also I messed up. Yeah, something like that. Okay, so provides loans, okay? Now our loans will depend on the branch, no? Like, so that's why there's total participation from the loans ka side. And one branch can provide n number of loans. So 1:n ka relation. Okay. Now each account should be uniquely identified. No, so it will have something called as account number. That's its primary key. And for loan also it will have something. No, like let's say loan number. That will help us uniquely identify each loan. Okay. Now even in a loan, as you can see, a loan and account. In accounts there are types, okay? There's a checking account and then there's a savings account. So now an account can either be one, no, a checkings account or saving account. It can't be both at the same time, correct? So an account can be a disjoint thing of, we'll have a savings account and we'll have a checking account. I just wrote account in short, but actually you're supposed to write the entire thing, but even this will do, okay? So yeah, there are two types of accounts, savings account and checkings account, वैसे. And now as for our loans, there are two types of loans, car loans and home loans, no? And now a loan can either be a car loan or a home loan, right? So it's not overlapping but distinct or disjoint. So we'll be having a disjoint specifier over here. So this tells us that if there exists a loan entity, it must be either a home loan, for example, home loan, or it can be a car loan. वैसे. Now, what else do we have here? Now we need each account to have a transaction table, and each loan will have its payments table. Let's do loan ka payments table. Okay, so each loan has payments. Okay, so like installments or something. वैसे. Now the payment can be a, what do you say, weak entity, okay? Because payment can be dependent on loan, no? You can only make a payment if the loan exists. So from the payment ka side, we have total participation. And one loan can have n number of payments, correct? So yeah. So that's there. And then we can have, what do you say, payment number as your partial key. Partial key, that's why I put a dashed underline, okay? So this is the rough structure so far, and now we need one more thing. Each account ka transaction, na, whether we did deposit, withdrawal, or we used a check. Okay. So for that, I don't actually have space here. I should have planned this out better. Okay. But since I don't have space here, I'll just do account has, now it has transactions, no. So we'll put transactions here. Has transactions. Now a transaction can be either what do you say, a withdrawal, a deposit, or a check, no? वैसे. So it can be only one of the three. So we'll have a disjoint relation. 1, 2, 3. It could be a withdrawal. It could be a deposit, or it could be a check. There's no other possibility, no? So this is the transaction card details, and they said both of these must include the amount, date, and time. Okay, both of these as in our transactions as well as our payments. So our payments must include the date and time. So we'll have one thing for our date, one attribute of date, then one attribute of time, and also include amount also. Amount, date, and time. Sorry, three things. And we also need the amount, no? Like how much amount you're paying. So amount, date, and time. And same for this thing, okay? We'll have an amount. Then we'll have a date, like the date of the transaction. And then we'll have the time of the transaction. At what time the transaction took place, okay? So we'll have time attribute. Now the transaction should have its own number, a unique identifying number, no? So we'll just call it transaction number, and since it's the primary key, we can underline it, okay? वैसे. So now we have a EER schema. If you want, you can add more details like name of the bank, what do you say, like headquarter city, if you want that, like where the bank originated or where the headquarters of the bank is. वैसे. Then we'll have for branch, we could just have, for branch we don't need anything actually, because we already have the branch ID and the accounts and stuff. For accounts, we can have the name of the person who's holding the account. Then we can have the balance. Obviously we need the balance, no? Like how much amount is balance in the account, stuff like that. You can add more stuff if you want. I'm just adding a few things. Then loans, okay? Here we have home loan and car loan, payments and stuff. Yeah, pretty good. If you want, you can even add attributes over here, okay? Like we have car loan, no? So we can add, what do you say? For example, car, what do you say? Like the car ka manufacturing number, for example. Car ka manufacturing number. And we can also have the car ka registration number, reg number. वैसे. And we can use this also as a primary key if you want over here. But yeah. And for home loan, we can just have the address because the home won't move, no? वैसे. So we got this also, and yeah. So basically, this is about it. We made a extended ER diagram. You can add more details and stuff if you want, but this is like the basic layout, okay, of how your extended ER diagram will look. Extended ER diagram. Nice, sir.